Dan Williams, if you're talking to us, we can't hear you
Okay, sorry. Is that better?
much.
Okay, so anyway, we'll get started. Recording is on, um, and if nobody else has any other topics, we'll just kind of go through the list of outstanding questions that I put down. Again, if you come up with other things to talk about today, drop them in the document, the agenda document, which is in the in the Zoom chat. So to start off with, what actually is the network object? I think, Mike, you have talked a lot about network attachment. I think we should come up with a nice, concise definition of exactly what we would like to put into the CRD. To some degree, yes, I think it is a network attachment, and the custom resource is a description or definition of how to create an attachment for a given.
Exactly. It is not a network. It is not an attachment. It is a description of how to make an attachment.
Yes. Although I would point out that due to the way CNI is structured, one of these things, the result of one of these things, could result in multiple attachments, I think, as you define them, Mike. Because I think as you define an attachment, it is either an IP address or an interface. Is that correct? As in, if you're talking about a layer 3 network, then it's an IP address. But if you're talking about a non-layer 3 network, then it's an interface or a MAC address.
I think it's an important thing to be clear about. I think we have some choices. I kind of think the sense of the group is we want to focus on a network interface, except, of course, for the people who care about DBTK in ways that doesn't use network interfaces. I'd like to set the non-network interface part of the discussion, just put that in a separate box. I do think it's important to support stuff like Fido.net that doesn't use network interfaces. But let's discuss one thing at a time. Let's try and settle up what we can, focus on network interfaces, and then figure out how to add stuff that's not about network interfaces.
Okay, fair enough. Although I can think of scenarios with more SDN type networks where the SDN handles the attachment to multiple logical networks, as opposed, and that all goes through one interface. And in that case, you can think of a case where the interface gets multiple IP addresses, and each one of those is theoretically an attachment to a given network.
Well, as we discussed recently, even with a pure IPv6, a one network attachment will typically get you multiple addresses.
Okay.
In a dual stack world, you'll get a V4 and a V6 address. So there's certainly a distinction between address and network attachment.
Okay. So
I had suggested at one point just calling it CNI plugin because we don't actually have any requirements of it at all, other than that it at least one of the plugins comes up with an IP address for us to use, like a traditional plugin would use.
True.
And as long as it does that, the spec has no reason to care whether it creates a network interface or not, or creates 2 or 0, or, if we get back a usable IP address from it, then it's done its job.
Yeah, and maybe that's a way to sidestep the whole thing and the bike shed discussion on what we call it. Although I wonder, does that affect the ability to take some of these ideas and eventually move them upstream?
So I think even if we haven't yet converged on whether one network attachment means one network interface or one IP address, or exactly what it means, I think we do have a concept here of network attachment that we're circling and trying to nail down. And I think it is about the right kind of abstraction, right? We want one invocation of one of these things to make one network attachment.
Okay. Yeah, so kind of following Dan Winship's thought, what if we kind of define network attachment or network or whatever we're going to call this as one CNI invocation of add or delete?
Yeah, I mean, I agree. I mean, that's what the thing is a description of how to invoke CNI.
And that sort of sidesteps the question and leaves some things undefined, because CNI has its own semantics around what constitutes a network for the purpose of add and delete. And specifically, that is a tuple of the network name from the configuration and the container ID.
I'm not sure that's the right way to characterize it. Network.
Well, go ahead.
Yeah. I've always found CNI to be a little bit schizophrenic in that in some sense it talks about a plugin is a binary that you invoke, and then there's this file that gets fed on std-in, and if that were all that were to it, then you can think of what gets fed in as on std-in. In fact, the spec I think calls it something like a network configuration, right? So that's really a description of what you're connecting to. But in fact, in Kubernetes and in everybody else's mind, as far as I can see, this file that gets fed in on std-in is also, and now in the spec as well, this file that gets fed in is not only fed in, but it's read by things that invoke CNI plugins to discover stuff about the capabilities of CNI plugins.
Yeah, and that's kind of grew out of some of the things that got added along the way as we added capabilities to Kube and to CNI.
Right. My point, though, is that this file, and there's been a lot of pain about the fact that it's a file, right? And part of the real, I think, source of the pain is that it's serving two purposes. It's serving to describe to higher layers how to invoke the if you think of this plugin as what we're talking about, a way to make a network attachment, it is telling the higher layers some things about this way of making a network attachment, as well as giving input to the CNI plugin, helping to tell it how to make the network attachment.
Yeah, that's true. And while those are theoretically two different things, I'm not sure how you would better split them.
You could just split them, but I think that's not a very important point right now.
Yes, and that's true. But I think in the end, the configuration, which is essentially the CNI JSON, is the description of how to attach to a particular network, right? We can all more or less get around that. Or it's a description of how to create an attachment to a network.
Right.
So, and that could be composed of multiple plugins as a config list, just to be clear. All right. Anybody else have thoughts on that? I guess the next question is, do we bike shed on that and call it something?
Yeah, again,
else?
I think the next question is, I think we're agreed then that what we're talking about is a way of using CNI to make a network attachment.
Mm-hmm.
Right? So
sure.
We want a name that reflects that without being such a big mouthful.
It literally could just be CNI config.
Is that a technical term in CNI?
Let me check. CNI calls it a network configuration.
Right. Is there something else in CNI or Kubernetes with the name CNI config?
I don't think so. Could be wrong, though.
Yeah, what's in the library? Is there a type in the CNI lib that is CNI config?
There's a network config type. And yeah, you're right, there's a CNI config as well. Although that is a little bit tricky because CNI config itself CNI config is actually a list of paths in which to look for plugins in libcni, whereas network config is what we think of and what we're discussing here as the JSON network configuration. Does that help?
It helps. I mean, it's information. So I would not recommend calling it CNI config just for the sake of avoiding the confusion.
Okay. I mean, I guess CNI.
How about, well, again, but it's not a network. That I don't want to just call it a network. How about CNI attachment config?
Well, how about we cut this off and duke it out over the list? Since it seems we can bike shed for a while on this, and at some point we're probably just going to make an executive decision.
Right. Okay. So in the meantime, can we just use a name that reflects the fact that it's a way to make, one of these describes a way to make CNI attachments?
I think until we come up with a final answer, I mean, if we rename it now, we have to either also rename every reference to it and everybody's comments all throughout the spec, or have comments that no longer use the same naming. And so let's just leave it as it is until we come up with its final name.
Sure. That sounds reasonably. Go ahead.
Yeah, it's led to a lot of, the name's led to a lot of confusion, but all right, fine.
Yeah. All right, next item is network status as an annotation versus a custom resource of its own. I mean, essentially an annotation versus a cube object. So I think
it's not just status. It's not just status. It's spec as well, right? So I think I think there's two ways we can go about this.
So
one is have a pair of annotations that have spec and status. And the other is have a separate object that contains spec and status.
So I'm not really following on spec. With Kubernetes, spec is usually part of the object itself. It doesn't get its own object with annotations and metadata and labels and stuff.
I'm sorry. Let me try that again.
Okay.
The two directions we could go is, one is have two annotations per pod. One is spec of a collection of annotations, and one is status of a collection of annotations. The other is have a collection of objects, each one of which describes the spec and status of one attachment of that pod.
Right. So
what do you see being in the status here?
I mean, essentially the status was supposed to be the CNI result. I mean, what people are really interested in is what are the details of the attachment that this CNI call resulted in. IP address, MAC address, perhaps name.
So the status is going to be per pod, unlike the spec, which is there's only one spec that all pods using the same network would be sharing.
Right.
Wait, slow down. We need a status per attachment.
Yes, that's what he's talking about.
But
so I skid the two ways I can see to report status is one is each pod has one attachment that has a collection of statuses. The other is each pod has a collection of associated objects, each of which has status.
I think you misspoke there. You mean one annotation that has a collection of status versus individual objects, each representing one status of one attachment, right? Okay.
Yes.
Okay, so we are not talking about adding a status field to the network objects to go along with its spec field.
Correct.
Right, we're talking about status of an attachment, not status of the thing that describes how to make an attachment.
Yep. So you and I had some conversation back and forth in the Google Doc comments, Mike, and let's see. Trying to I'm thinking of one particular comment that you had that I was asking about. Okay, so I guess I'll just go over it here. So the only reason that I can see for doing the annotation side versus the object side is that if you do the annotation, then it's always on the pod already and you don't have to do any additional lookups. But then the second point there is that the thing that receives that status, essentially the plugin that is implementing the specification, would not have to write that back to the API server as an object. It would only need permissions to update a given pod. I don't know if that makes a material difference for security policy for Kubernetes, because most network plugins that do these things would have a service account. or something like that anyway that would give them permissions to update most things. But my only concern there is it seems like it's a little bit more bookkeeping to have separate objects for each of these statuses.
I agree. It is more bookkeeping. The virtue of it is for the sake of clients who want to look things up in the other direction. If you have a network or thing that describes how to make attachments to a network, having these separate objects makes it easy to find all the things that have actually used that method to make an attachment.
Right. Are there any security implications either way? For example, if it was a separate object, we could apply different security policy to it, right? As opposed to, as a pod, anything needs to be able to read a pod, whereas annotations could also be read by anything that can read the pod, right?
I think it is actually makes the security story a little bit easier. I think it's easier to secure a separate object than a particular annotation.
Yeah. Is there a use case for doing that? Is there, I mean, for example, would we want to restrict reading of these details in any kind of reasonable deployment?
Well, I mean, there's the general rule, of course, that you want to separate namespaces and so on. I don't immediately see.
Well, I mean, I would be assuming that if they were separate objects, they would be namespaced in the same namespace as the pod.
Yes, I would too.
Okay.
Yeah, but then if somebody needs an IP address for that pod, they will have to make two calls. One will be to get pod, which is the IP address done by the default plugin, and then you will have to do a CRD call to get other IP addresses. So there will be two calls because of that.
And you also might have to watch or have multiple watches into Kubernetes, or at least multiple filters on the same watch stream.
So where, you were talking about annotation versus CRD now, but where do we imagine this data going when, if we weren't a CRD, if we were like actually fully integrated? Would we expect this to be a field in pod status?
Yeah.
So if we're going to do that, I feel like it makes more sense to have it as an annotation on pod rather than creating a separate API object for
Actually,
it.
I shouldn't have agreed. Yeah, I mean, this distinction is a distinction that can be carried forward. So yeah, I think it's even if we succeed in getting this idea into mainstream Kubernetes, it still makes sense to have separate objects because again, it's the easier security story, but more importantly, it makes it easier to look up things by that.
Unless we want to update the network object or the CRD object with all the IP address information, then in that case, we can say that if you need this IP information, you just need to query this object rather than doing a get pod and getting one IP address from there and the other IP addresses from the pod, from the CRD. So if the CRD can have all the information about the networking for that pod, that will solve the purpose.
Well, I wasn't proposing an object that has information about all the networking for one pod. I'm suggesting, I'm not quite sure I want to go as far as advocating, but I will say that I have colleagues who advocate this approach. We define two kinds of CRDs. One describes, as we've been discussing, how to make a network attachment. The other describes, in its spec and status, the one particular network attachment of one particular pod.
Anybody else have thoughts on this? I'm sort of ambiguous on it. I feel like it adds, to do it as separate objects, adds some complexity that as a plugin implementer I'd, possibly not want to do, but.
And that complexity being the extra query to find these things?
The extra query, the extra watch, having to create these objects as opposed to just update the annotations on a pod that you already have.
Well, the plugin doesn't create these objects. The user creates these objects.
Okay, that's right. That's what. That's one of the comments that I was wondering about. Can you elaborate on what you mean there?
Sure. I'm saying instead of a user one way we could go is a user writes an annotation on a pod saying, here are my desired attachments for this pod. The other way we can go is the user creates a collection of objects for the pod, each one describing one desired attachment for the pod. In both cases, the user is creating the declaration of what's desired. What the plugin does is it either updates the annotation on the pod that has all the statuses, or it updates the status in each of those individual attachment objects.
But if they, okay, so this is, I guess I was not quite understanding where you were going with that particular conversation. If the user creates additional one object per attachment per pod, then would they still also create an annotation on the pod to point to those objects?
No need for it.
Okay, so you're proposing that something that wants to, that the, let's see, the plugin that is running would have to then go query for all of the attachments that match a certain format, which is somehow derived from the pod name and namespace?
It would have, it would, so I guess there's a couple of ways you could think about doing it. Let's say the most simple and direct way would be a plugin that wants to, say, make, well, I don't want to say this. Okay, we're getting into other parts of the discussion, which is who's responsible for making this happen. Let's just be vague about that for the moment. The thing that makes these happen, right? One way, simplest, most direct way to do it is when it's time. We're still getting details. So let's say when it's, dang it. Okay. Okay, I'll be specific.
All right, go for it.
Let's say it. Okay. Let's say, for the sake of argument, that the attachments on a pod is not dynamic. So at pod creation time, somebody has to find all the desired attachments for a pod. And that somebody or something could do a list operation with a suitable filter that would return the attachment objects. Each attachment object would refer to a pod and one of these other CRDs that describes how to make a network attachment. Right? So it's basically a pairing object. Right? So the thing that needs to create the pod and its attachments would query for all these pairing objects that refers to the pod at hand.
So is this a way to get more dynamic network attachments than Kubernetes already provides?
I think we can do that either way. That's
okay.
Not the nub of the issue, which is why I didn't go to the dynamic part yet.
Okay, I mean, I guess I'm not. The downside of that to me is that you would create quite a few more objects that I think would basically be the same as a annotation on the pod that just lists off the names of the attachment descriptions? Or is there something I'm missing there?
Yeah. Well.
I mean, again, aside from the way to get this information is different between these two methods.
I have to ask, you talked about an attachment that lists the attachment descriptions?
No, an annotation that lists. So as the current proposal has it, there's an annotation on the pod and it just lists the names of the network attachment descriptions. What you're proposing is that instead of that annotation, there would be a pairing custom resource that would list the pod and possibly using label selectors. I think you'd mentioned in the Google Doc. No? Okay. So it would be a per pod object that lists the pod somehow, and then also the network attachments that pod should have. One attachment? Okay.
One attachment technique or prescription or engine or factory, whatever you want to call it.
Right. Okay. So I think I understand that now. I mean, like I said, I feel like that would be a lot of objects because you need at least one object per pod.
Right. I'm imagining that in the common case, you don't need a lot more than one. But in some use cases, you would have many.
Okay. I mean, to me that, yeah, it might be more flexible, but also seems like it would kind of interrupt the flow a little bit, because then you kind of divorce the selection of networks from the pod object itself. I mean, what you're essentially trying to do is you're trying to take a pod and you're trying to attach it to certain networks. And so now instead of creating one pod definition, and that pod definition says attach to these networks, you create a pod definition, and then you also create one or more other objects somewhere else that describe how to attach the pod to certain networks. So I guess that's the major downside I see.
Does this mean we have twice as many objects as a minimum, or would you not have such extra objects if it was using the default network?
Well, that touches its toe in the default network discussion. We could go either way there, I think.
Well, I think and correct me if I'm wrong, Peter, I think what you're saying is that if in the current spec, if you don't specify the annotation to select any network attachments, then you just get the default networking, right? And what you're saying is that if you do the same thing in Mike's scenario, would there be one object per pod or not, right?
Yes, and my concern is that in the minimum case where somebody doesn't want to know about all this, we just want to have the default network go away and keep it easy for me, are we making things more complicated? Because if so, that would be a problem, and I think would be to push back.
Yeah. I would think that you would not require another object, that by default, in Mike's scenario, that it would just continue with the same behavior if you couldn't find an attachment for the pod. But correct me if I'm wrong, Mike.
Yeah, I agree with that. No, I'm more concerned now that I think about it. I'm sorry I didn't think about this earlier. I'm thinking about the, as you say, flow of just creating a pod. If you do want multiple attachments for a pod, if we do have them as separate objects, do you create these separate objects first or later?
Yeah.
There's no good answer there. Both have problems.
So do you see specific downsides with the annotation approach at the moment? Can we start with the annotation approach at the very least?
Yeah, I think we can. Again, the downside, I would just say the downside is really the complement of the upside the other way. The upside of making them separate objects is it's easy to query not only for all the pairing objects that are relevant to a given pod, but all the pairing objects that are relevant on the other side to a given network attachment factory.
So essentially, it's easier to see all of the pods that are attached to a given network.
Right. Roughly, yes.
Yeah.
So in theory, we could update the network object. If it did have a status component in addition to spec, it could list all of the pods that were attached to it.
I really wouldn't want to do that. That's going to have a scalability problem. If you get lots of attachments, then the cost of updating each one is ON, and it's really painful. A better answer, I think, would be to create a separate indexing service so that there's something that would efficiently serve that query based on a cache in memory.
Well, so for the moment, we will continue with the annotation for network selection. And we'll keep this point as something to think about. And Mike, if you do have the agenda doc open, if you want to update the agenda doc with the advantages that you see for the CRD bit, maybe clarify the...
Sure, I'll do that offline, but I agree. Let's
Okay.
proceed on the assumption that we're going to
fine.
do attached annotations.
Okay. Okay, so next up was the default plugin discussion. And that there's a couple different issues here. And the first one is which attachments, IP, and other details get reported to Kubernetes, because Kube only allows one at this point. The second one is which one should get the default route inside the pod's namespace. And perhaps 1 and 2 should be the same one, maybe not. And then the third one is what should be used for health checking by Kubernetes. And I know, at least for the health checking discussion, in the past, we've discussed in sig-network of having, for example, a link local address that could be assigned to the pod for health checking. And I've come across some other scenarios where that might be useful as well. So
I'm not sure we need to.
Aspect.
I think we're kind of going off the rails here because
Okay.
we've already decided, right, that the spirit of what we want here is there's one main network, and then we've got these sidecars. And we have to I have to digress a little bit to talk about this word network because I think it trips us up. Because sometimes when you say network, we think Ethernet or virtual Ethernet. And sometimes we mean something deliberately, strictly higher level concept, which is just all the IP addresses that can talk to each other. And so I want to focus on that latter one. And I've been using the word or the term plane of IP connectivity instead of network just to avoid confusion, right? So what we're trying to do here, and I thought we all agreed on this, was that the design is there's one main plane of network of IP connectivity. Right? It's the one that you get if you don't use any of this special stuff. It's the default one. It's what Kube will do. It's what services will use. It's what go in endpoints. It's what all the rest of Kube is going to use. Right? So I thought we had agreed that there would be that for every pod. Every pod participates in that. And we're talking about an annotation or whatever to make additional sidecar attachments to additional sidecar networks, which may or may not be separate planes of connectivity, of IP connectivity.
Okay, fair enough. What I had thought we were talking about was this annotation would change the Kube default behavior and then just select the networks in the annotation, as opposed to having a default that was always configured and then the annotation would do additional.
But Mike's version is a lot simpler, and it solves use cases that I've been thinking about. I don't know for sure that it solves everybody's use cases, but
So to be clear, what we're talking about here is, does every pod get onto the default network? Is it a default network plus optional networks, or is it default network or optional networks, which may or may not include the default network?
Provided by network, you mean plane of IP connectivity. I thought we'd already agreed that the pod gets on this default plane of IP connectivity, plus optionally other attachments, which might also provide IP connectivity into the same plane or not. That's a detail that we don't need to fix. I mean, set in one way or the other.
Yeah, I agree. Like the default network needs to be there. So, but other than that, like I agree with Mike.
Okay. Certainly for our use cases, and I'm talking from a telco kind of environment, we can't think of any reason why that would be a problem having the default network all the time. So it's really a case of, does someone have it, and if it makes things simpler, let's do that. But unless someone's got a use case where that's a problem, somebody else comes up with one.
I hadn't necessarily thought about that yet either. So I don't have any particular problem with it. I think the only issue might be if we eventually talk about overlapping IPs and things like that. If you have a sidecar network that overlaps with the IP range of the default network, then we'd have to start doing some dances.
Yeah, I agree with you, Dan. I think that's something that needs to happen.
Right, and I was thinking that in the real use cases, we can simply arrange that the default network's IP range, IP space does not overlap with the sidecars. But now that you mention it, I recall hearing in a previous meeting someone from the NFV world saying, no, that's not true for them.
I think that was Pear.
Yeah, it's my world too, right? Like, so it's the same idea. Like, we don't have control of what address go in there. And I done a little bit more thinking about this, right? So this is not just the NFV world. So think of like a VPN gateway that somebody implements here, or somebody who wants to call back home, right? Like using a VPN, like we could end up with like the same thing if you have like address injection coming in, right? So like somebody could like decide to use the same 10.0 network like that Kubernetes is using, for example. So I think it's probably more common than like I at least initially thought of, but I think we need to support it.
Yeah, we've got use cases as well. We've got session border controller, and we often have multiple customers on a session border control, and some of them will have picked overlapping IP addresses. And that applies not just between the default network and some random network, but between two networks that both have interfaces to the SBC. So you have to worry about that. I have no idea how we would fix that, but I'm not sure this makes it any easier or harder, frankly. So.
Yeah.
So I don't think it makes it easier, but I think I agree we need to fix it.
So I guess kind of what I'm hearing is that most people don't have a problem with having the default network, which Kubernetes sort of right now always attaches to a pod. Having that default network always attached to pods here as well, and this annotation would be additional sidecar networks. And the overlapping IP discussion, we need to continue talking about it, but it does not have any particular effect on the annotation and this behavior because it's already a problem with that behavior, and it would also be a problem with sidecar networks anyway, right?
Yeah, and doing this throws away the question that we were currently on about how do we indicate with the sidecar network's default route and health checking. We just don't care about any of that now with the network object because that's all part of the default network, not the networks that we're defining here.
Okay, that makes that easy, and I will update the doc to that effect after the call. So the only question I have left on that then is the current Cube default behavior is somewhat unfortunate with respect to how it actually picks CNI plugins. Is there a better way to specify that?
I don't understand the question.
Yeah, what is unfortunate?
So what happens right now is Kubernetes just looks in etc CNI net.d, and the first file that it finds sorted ascibetically is the one that it considers the default network. So what this means is that you have to be very careful about how you name things. So for example, you would need to name something like...
well, slow down. Whoa, wait a minute.
Sorry, go ahead.
You're assuming that what we're doing involves putting files somewhere.
Well, it does for the purposes of how this plugin gets called. Because to actually get this meta plugin called, so assume we're talking about, for example, Multus or CNI Genie, doesn't matter. You have to put a multus.conf into etc CNI net.d, sorting earlier than any other config in that directory, and then Kubernetes will find it, and then Kubernetes will call Multus or CNI Genie, which then implements this specification. If you do happen to have other files on disk, say, for example, I think
the answer here is just to say if you use the network object, then it bypasses normal CNI search paths. And whether Kubernetes is directly implementing the Multus-like behavior or it's actually calling out to Multus, it just happens correctly regardless of what CNI config files you have installed with what file names.
Okay, so in that case, then we need to talk about the specification from the, in the network spec struct. Because currently as it is, there's 3 different ways to specify how to call a CNI configuration or configuration list. One is to embed the config into the network spec. The other one is to specify the plugin binary name specifically. And if you do neither of those things, then it currently will look on disk for a config file.
I don't think that's a conflict or a problem.
Okay.
But before we go further with
it just means you have to be careful about how you name things.
I think what Dan Winship said means it's a non-issue. But before we continue with this, I think you skipped something that belongs with the earlier discussion.
Okay.
Regarding the default, which is that currently CNI plugins are making the one and only connection. And so they normally set a default route and provide DNS client configuration.
Yep.
But for the sidecars, we want them to not set a default route or provide DNS client configuration. Now,
to be clear, they could provide DNS client information, but that information would potentially be thrown away because it does not materially affect anything inside the container's network namespace. It's essentially only reported back to Kubernetes or Multus, Genie, etc. in the result struct. But where I think you are correct is that plugins currently do potentially modify the default route inside the namespace in certain circumstances. And that's what we need to be careful about.
Well, help me out here.
Okay.
Let's see.
So with basically 2 things. Cube currently doesn't care about DNS information from CNI plugins anyway. It just throws it away. That's something I'd like to change.
All of it, including the search path and...
Oh, yeah. Yeah, totally. Yep. Yeah, I know. And it's been like that for years, and I'd like to change that. And I looked into that, and there were some complications around backwards compatibility. There's a whole number of ways that you can tell Cube to set up DNS. By default, I think it copies resolve-conf into the container. Other times, you can have it add its own DNS servers so that you actually go to cluster DNS as opposed to your host's resolve conf. And there's a couple other options. I think you can actually embed name servers into like the kube config itself, like through command line and stuff like that too. But another option we could add is, use the information from CNI. And that would be great because then, the default network could return DNS information that would actually get used, and that would solve a lot of our problems around multi-tenant DNS and things like that. But we're not there yet. So I think you're totally right on default route, but currently I think DNS is thrown away.
Okay, well, for default route, my next question is, are we already done? Because is it the case that what most plugins actually do is they set a default route if there isn't one already set?
That is a good question.
I think most plugins assume that no other plugin is being called.
Yep. I think that's usually the case.
It usually is probably not good enough. We might have to do something to... I mean, we could possibly even get the CNI spec changed to something that says whether...
Well, I don't know if we have to change this. I'm trying to say we don't necessarily have to change the spec. All we need is that these sidecar attachments are made by plugins that have this simple behavior that either they don't set a default route ever, or they don't set one if there's already one there.
The CNI spec, as I recall, assumes that you call the CNI plugin once for each network interface, which I don't think anyone actually does in practice, but I think that's what the spec assumes in its description, which makes me think that in principle the CNI spec wouldn't allow every single plugin to set a default network, because that wouldn't make sense. So we may actually be okay here, although in practice I bet there's some CNI plugins that don't.
Yeah, no, I think in practice, right, the way it works is there's one that makes the loopback, and something in Kube, I think, calls that one in addition to the configured one. And all the configured ones think they're the only one doing anything besides loopback.
More or less that's how it works right now, because typically you don't run multiple network attachments in this way. So I think I said in the comments in the doc too that there's definitely some room to clarify this. There are workarounds though. For example, whenever Multis or Genie or whatever runs one single CNI configuration or config list, it could somehow enforce default route, that kind of thing. So, or it could read the default route and then replace it after the plugin runs if it got clobbered or something like that. I mean, there's ways to work around it for now, but I think we definitely need to clarify this, including perhaps in the CNI spec, maybe even in this spec.
Yes, I think the simplest and probably best for the reason that Peter mentioned, in the CNI kind of begs this question, and it really is properly a CNI question, right? CNI needs to get more explicit about whether the caller of a plugin expects this plugin to establish a default route or not.
Yep.
And in lieu of that, or until that, I think the easiest way to work around it is simply by actually using plugins that behave in a convenient way.
Yeah, I'm not sure there's much we can do other than, if a plugin is behaving badly, then that plugin needs to get fixed for the moment somehow.
Right. I mean, it's code that, that we can control. I mean, yeah.
Okay, so last item, and I think you brought this up, Mike, but there are some other use cases for it too, pod-specific details that shouldn't necessarily go into a network object.
There seems to be a misunderstanding here.
Sure.
And again, this network object terminology is so confusing.
Network attachment description.
Okay, right. So at least in the use case that I've been working on, which is, again, it's VMs in pods, and for a traditional VM type of service in which the user has the options to specify the IP address and the MAC address and some cost constraints on each attachment. So, those are per attachment details that are optional.
Yep, but they do not go into the network attachment description, because that description is common to all of the pods that want to attach to that network.
Again, description doesn't clearly have the one-to-many relationship, so that's why I was to use words like factory or engine, right? These details don't go in the factory because they're specific to each instance.
Yep. Yeah, so the option here is that we could add additional annotations to the pod that are specified by this document that describe things like requested IP address, MAC, that kind of thing. QoS is already sort of handled by some things in Kubernetes, although it's not particularly descriptive. There are bandwidth annotations already in Kube that are kind of de facto standard.
Really? Where?
Yep. Let me find those for you. Well, in lieu of actually spending the next 2 seconds or 30 seconds in silence, they exist. I can tell you where they are on the list. And they've been around for quite a while. And it was kind of a
Okay.
at the I think in Cube 1.2 or 1.3, they got specified so that the internal Kubernetes networking code and KubeNet, essentially the predecessor to KubeNet, could implement some bandwidth stuff.
Okay.
They're pretty limited. Again, they're basically egress and ingress bandwidth limits. So you say this pod gets 5 meg, no more, in and out, and that's it.
Mm-hmm. Yeah, that actually works for my current use case.
Okay.
So the downside, though, is that's going to have the wrong cardinality. That's going to be 1 per pod, not 1 per attachment.
Yes, that is correct.
So I think maybe rather than kludge up additional annotations, I would suggest making the one annotation more flexible, so that each the annotation that describes desired attachments is not a list of strings, but is rather, say, a list of JSON objects, which can have other fields as desired.
Yep, fair enough. Okay, I can try to write something up along those lines in the doc for the next meeting.
One other question, just a simple procedural question. We've kind of resolved, or we're kind of focusing our attention downward from all the larger space of possibilities. Would it make sense to write a fresh doc, taking the things that we've kind of tentatively settled here as settled?
It might. Is there a problem with updating the existing one and just kind of simplifying, clarifying, resolving some of those comments?
Yeah, if the doc is updated to be non-conditional, or at least point out here's an alternative that we considered but dismissed, and is clear about the direction we're pursuing versus all the ones we're not. Yeah, that would work.
Okay, yeah, I can do that. I can add a section to the bottom to talk about stuff that we've talked about and then put aside for the moment. Okay, in the last 5 minutes, is there anything else anybody wants to discuss?
One fairly short thing was mentioned that services wouldn't be affected by these additional, sorry, I'm going to call them networks because I haven't quite got my head around the new term. But so we've got additional interfaces on our object. Will the IP addresses for those appear in services, i.e. in DNS? Or is that undecided?
At the moment, the specification specifically states that it is up to specific plugin implementations whether these sidecar networks have any interaction with services and other components of the Kube API. We had a long discussion about how this would impact services last fall. And out of that discussion, it seemed like there would be quite a lot of impact, and we weren't quite ready to start changing the Kube API in those ways. So for the moment, I think this spec just kind of concentrates on the sidecar networks. And by sidecar, we mean things that Kubernetes is specifically not aware of at this time. But that doesn't mean that a plugin couldn't somehow, implement services on these networks if it wants to do that.
Yeah, and by services, all I'm really referring to is service discovery. That's all I care about, which is DNS. And that's,
okay.
So, I mean, the rest of services is all very nice, but we don't rely on that. But we do usually rely on DNS lookups being there. But it sounds like we could, that's not really a big, not having that would be a problem, but it's not that we don't have it. It's just that we'd have to do some work to implement it in our plugins, which I think is fine.
Yep, correct. Yeah, I think it's something that we do need to address. And, if we do end up formalizing these kinds of concepts better, it clearly needs to be addressed somehow.
Yeah, I'm really confused by this discussion. I thought we had just decided nix for now on all of it. And there's two sides of it, right? One is with these sidecar attachments, do they provide endpoints? And the other side is, can they be used as a client of a service? And I'm not sure which Peter or you were talking about.
I mean, you can think if you do have a service provided on a specific network, that's interesting. I mean, you could write all kinds of controllers to do what you want.
Well, again, like you said, we discussed stuff that's a lot of work and not well thought out. So I thought we were just explicitly punting on all of that for now.
Well, we are.
Yeah, and I mean, it may well be that I've missed most of these calls so far, so I may well have just missed where this was discussed, sorry, but I'm happy with a model where we need to set up some endpoints. We have to write some code ourselves to say, go scan through objects, read some annotations, and write out the endpoints out of band and write our own controller. Something like that as a future plan for something we might have to do, either as a company ourselves or, as something that will become part of Kubernetes later. That I think.
Yeah, but it doesn't end there, right? So if you say, oh, I'm going to add endpoints, so now a pod is represented multiple times on the endpoints list, what have you done to load balancing?
I am not interested in load balancing from this point of view. All I want is DNS. And so from the point of view of my use case, right, I can get my use case by writing some code from what we've got. That's where I'm going from this. So I'm kind of happy. I'm saying, fine, I don't have a problem. I understand that as soon as you start trying to use a Kubernetes load balancer, you have a problem because these additional networks really are different. And all these sidecars may be on a network which is just completely different characteristics where it doesn't make sense. As soon as you try and describe all that, it becomes problematic.
Well, not just the Kubernetes load balancer, any load balancer that consumes endpoints would be used.
Yep. Yeah, so suffice it to say, all that is explicitly a non-goal of this specification and left up to plugins to implement if they want to.
Yep.
So, okay. And
my problem here is I think we should go farther. If give plugins the options of making extra networks, we've just confused a bunch of stuff. I think we should explicitly say, no, plugins do not make extra endpoints.
When you say extra endpoints, what do you mean? Do you mean endpoint objects in the Kube API, or do you mean extra attachments?
I meant extra endpoint objects in the Kube API.
I would leave that up to the plugins because if they want to, then essentially, I don't see the difference between putting this, the sentence in that I had put in, which is it's up to the implementations, and just leaving that out completely. If you leave it out completely, then we just don't address it, and plugins are going to do that anyway if they want to.
Right. I wasn't proposing leaving it out. I was proposing putting in a different sentence that says that these sidecar attachments do not result in additional Kubernetes endpoint objects.
But is that saying that I can't write some piece of code, some container that runs over, looks through all my pods, finds what guys are on some networks, and puts them into an endpoint object that I can then do DNS lookups from? Because
you can do that, but the service controller is going to overwrite all of your endpoints the next time it updates the service.
It only does that if you've got an endpoint that is attached to a service that's got, I can't remember exactly what the reason is, but there is a way of setting your endpoints up so that does not happen. I think you put in no filter or something.
Yeah, there's a selector. If you omit the selector, then the endpoints are explicitly managed. And I think that is not forbidden by what I proposed. What I proposed to say was that the plugin doesn't make endpoint objects. I'm sorry, I didn't say that. What I meant is the plugin, the CNI, invoking the CNI plugin doesn't make extra endpoint objects. If you want something else that makes extra endpoint objects for your own purposes, nothing would stop you from doing that.
Yeah, and I don't think it'd be right for the plugin to do it because there are too many loose cases of I've leaked some IP addresses, all the rest of it. Whereas something that can scan periodically and catch all those leaks and say, oh, I see you've created that, that could be smarter about it. So I mean, I'm quite happy with leaving it fairly vague and leaving it to us to do stuff, because the reality is we're going to end up writing a separate thing that creates some endpoints by scanning over the pods that we care about. That's almost certainly where it's going, and it doesn't seem to break anything or interact with anything.
I think what I want to say is that what we're specifying here is the implementations of this spec do not cause extra endpoint objects to appear.
I'm not sure I'd agree with that, though, because I feel like that leaves out an avenue of exploration that we need to think about in the future if we want to get this into Cube itself anyway. I mean, we're going to need to explore some way, potentially, of making extra networks work with Kubernetes services. You know, 6-8.
So I think what we want to say is, for now at least, the service controller is not expected to pay attention to network objects, meaning automatically created service endpoints will not reflect anything that we do. We don't say anything about whether somebody else is going to manually create endpoints, because we have no reason to say anything about that.
Yeah, absolutely. If it's manual, it's
core itself will not create endpoints for the networks that added by this spec.
I mean, that works for me. Does that work for you, Mike?
We're out of time.
Yep.
I'll stop
Dan
here.
had the last word. All right. Well, I'll just put some of that language in, or if you want to put that language in to the doc, that'd be great too. And we'll see everybody. So in the custom resource definition de facto standard, right above network status annotation. So, and that's it. And we will see everybody on the 1st of February. So,
Good, guys. Take care.
Have a good one. Bye.
Thanks. Bye now.
Bye.
Bye.
Bye, guys.